Okay, so once quickly revise the things that we discussed in the last class. Yes, tell me what we discussed. Okay, what we discussed in the last class once చూడండి ఒకసారి బుక్లో stoichiometric calculations. Okay, so there we discussed about stoichiometric calculations means what? It involves mole calculations, mole mass or weight calculations. It means what? During a chemical reactions, reactant will be consumed, product will be formed. How much amount of product formed we can able to identify, or how much amount of the reactant used also we can be calculate. Okay, so now then after I started discussing about limiting reagent and excess reagent concept. Okay, yeah, let's discuss the same thing now first. Okay, so for again I am taking the same reaction that I used yesterday. H2 plus half O2 gives rise to H2O. So now as per this equation we have stoichiometric coefficient. Check once, is it balanced or not first. How many hydrogens here? 2. This side also 2. Fine. Oxygens are 1 here, like 1/2 into 2 means 1 oxygen atom only na. Yeah, here also it is 1. So everything is balanced. So after balancing the equation, now look at the stoichiometric coefficients. What is the coefficient here? We have 1. Here it is half. Here it is 1. It means in order to produce 1 mole of water, we required 1 mole of H2 plus half mole of O2. Okay, this is clear. Now my question is something like this. Given 4 moles H2 and 4 moles O2, then amount of or moles of water produced, moles of H2O produced, H2O formed. Very simple. Tell me how many moles it is? 4 moles. Why 4 moles? So let us understand that. Identify limiting and excess reagent from this. Chudandi, for every 1 mole we required half mole. Then for every 4 mole we just required here 2 moles. But how much we have? 4. So out of these 4 moles I can only use 2 moles. 2 moles remains excess. So remains excess means I can say this as a excess, remains excess now, excess reagent. This will be our limiting reagent. Now amount of product formed will be decided by limiting reagent. ఏది తక్కువ ఉంటే అదే డిసైడ్ చేస్తుంది. సో 1 mole కి ఎంత వస్తుంది? 1 mole. Then for 4 moles it should be also 4 moles of product. 4 moles of product is formed. Clear everyone? Yes. Next. Okay, now I given in terms of moles, but in the exam instead of giving in terms of moles they may give you in terms of weights also. Let us say 16 grams H2 and 16 grams O2 is given. Tell me how many grams of water produced or how many moles of water produced. Just simple. Yeah, understand it and tell me your answer. So moles of water produced or weight of water produced, you can find anything. Also identify limiting and excess. So this 16 grams of H2 is nothing but 8 moles of H2 I can say. Okay, and 16 grams of O2 means how many moles it is? 16 by O2 kada, then weight in the 32. So it will be 1/2, half mole only it is. So I have here 16 moles, here I have 8 moles, here I have O2 as half mole, then how much it is produced. See, first balanced equation ki ela undamma, 1 mole ki half mole is required. Okay, so for every half mole we required 1 mole of H2. Then for every half mole here also we should only use 1 mole. Ikkada ఎంత ఉంది? 8. So out of that 8 I can only use remaining 7 will be excess. So out of this I can divide 2 parts, 7 and 1. So this will react and gives you a final product. Which is limiting reagent here? O2. So O2 decides your product formed. How much product formed? Half mole ki enta vastundi? 1. Then for 1 half, for here also for half it should be 1. Is this clear? First equation రాయండి, బ్యాలెన్స్ చేయండి, స్టైకియోమెట్రిక్ కోఎఫిషియెంట్స్ రాయండి. దాని రిలేషన్ ఎలా ఉందో చూడండి. నెక్స్ట్ మనం ఇచ్చిన డేటాని అక్కడ సబ్స్టిట్యూట్ చేసి చూడండి, అంతే. ఓకే, డన్. నెక్స్ట్ okay, next one more question we will do, then we will move for percentage of yield questions. So, N2 plus H2 gives rise to NH3. Balance this first. So it should be 2, it should be 3, here it should be 1. Okay, so take the stoichiometric coefficients from the equation 1, 3, 2. Okay, now let us make a question. 17 grams of H2, N2 and 6 grams of H2 are given. Then amount of product formed, amount of ammonia formed. So tell me, very simple. So how can you solve this? So 17 grams means how many moles? 17 grams of N2 ante any moles? So we know number of moles is equals to given weight of substance by molar mass. So given weight is 17. Molar mass of N2 is 28. So this is half mole. So can I write here given as half mole? Okay. What about this H2 given? 6 grams. So 6 grams means in H2. 6 given weight is 6, molar mass is 2. This is 3 mole. Okay, so here it is 3 mole. Yes, tell me, which is limiting reagent, which is excess reagent? See, for every 1 mole we required 3. Then for every half mole it is half of this. ఇక్కడ ఇది హాఫ్ అయితే ఇది కూడా హాఫ్ కావాలి కదా అంటే సో అవుట్ ఆఫ్ దిస్ 3 mole we are using only half amount, remaining half will remains excess. అంటే ఎవరు excess reagent, ఎవరు limiting reagent? ఇక్కడ H2 is excess reagent, this is limiting reagent. అర్థమైందా కాలేదా? ఐడెంటిఫై చేయడం అర్థమైందో? మళ్ళీ చెప్తున్నాను చూడండి, ఇది ఈక్వేషన్ రాస్తున్నాం. ఫర్ ఎవ్రీ 3 మోల్స్కి మనకి ఎన్ని మోల్స్ ఆఫ్ నైట్రోజన్ కావాలి? 1 mole. దెన్ ఫర్ ఎవ్రీ 3 moles వీ షుడ్ రిక్వైర్ 1 mole. బట్ ఇక్కడ ఎంత ఉంది? హాఫ్. ఇది తక్కువ ఉంది కదా, మనం క్యాలిక్యులేషన్ ఎక్కడ తక్కువ ఉందో దాన్ని బట్టి చేయాలి. ఓకే, సో చూడండి, ఫర్ ఎవ్రీ 1 mole హౌ మచ్ ఇట్ ఈస్ రిక్వైర్డ్? 3. దెన్ ఫర్ ఎవ్రీ హాఫ్ మోల్ ఇట్ షుడ్ బి 3/2. 3/2 కదా, 1.5 అనొచ్చు. అంటే హాఫ్ మోల్కి 1/2, 3/2 అంటే 1.5 we use, remaining 1.5 will be excess. Okay, so that's why this is excess reagent. So out of this 3/2 will be used, 3/2 remains excess. Okay, yeah. Then next, how much amount of product formed ante every use cheyali? Limiting reagent. So for 1 mole how much it is producing? 2. Then for half mole it should be 1. అది ఎలా సార్ అని అనుకుంటే x అనుకోండి. ఫైండ్ x యూజింగ్ యూనిటరీ మెథడ్. సో ఎలా చేస్తాం? 1 గివింగ్ 2, half gives x. సో x into 1, that is x. 1/2 into 2, that is 1. So how many moles we are getting finally? 1. So in దీని weight అడిగితే ఏం చెప్తామమ్మా? 1 mole అంటే they ask in terms of weight, amount in terms of weight అంటే ఏం చేయాలి? 1 mole weight is how much? Molar mass. Molar mass of ammonia 14 plus 3 17 కదా. So how much amount of produced ammonia produced? 17 grams అన్నారు. ఓకే, ఇది ఎంత మిగిలిందంటే ఏం చెప్తారు మరి? 3/2 moles అంటున్నాం. సో 3/2 moles is nothing but 3/2 into what is the molar mass of hydrogen? 2. సో 2 క్యాన్సిల్ అయిపోయింది అనుకో, ఇంకెన్ని గ్రామ్స్ మిగిలినట్టు? 3 grams. సో అవుట్ ఆఫ్ 6 grams 3 grams is used, again 3 grams is remained. ఓకే, రాయండి ఇది. So more the number of you questions you practice, more clear you will get, more clarity you have, okay, from this chapter. Okay, from this chapter every student feel they can do the question in the exam, but examiner will make or he will frame the question to waste your time only, I already told. Okay, so it means you need to have more practice, more simplest approach towards the question. Done? Okay, next concept. Once read this question everyone. Riley. సరే అది దొరకట్లేదు మళ్ళీ సరే చేయండి. Once read this question, see 2a plus 4b read this, 2a plus 4b gives 4c. Initially if 2 moles of a, b is taken, then 1 mole of c is formed. Okay, so write the reaction. 2a plus 4b gives 4c. Initially how many moles they have taken? 2 moles of B and 2 moles of A is taken, then 1 mole of C is produced. Means this is the amount they have got, they are saying. Okay, next, then identify limiting reagent, excess reagent, what is the percentage of yield they are asking. Okay, easy, simple. One, C. As per the equation, if you observe, for every 2 moles how many moles of B is required? 4 moles. Then how much amount of product forming? 4 moles. This is as per the equation, right? As per the equation. Next, from the given data, initially how many moles they have taken? So given or taken is how much? 2 moles of A, 2 moles of B. Then tell me which is limiting and which is excess? So for every 2 moles how much it is required? 4. Then for every 2 here also it should be 4, but ఎంత ఉంది మనకి 2 అంటే కావాల్సిన దానికి తక్కువ ఉంది కదా. సో I can say this is limiting. So this can be a limiting reagent. Okay, now our calculation should be with respect to limiting reagent. ఇప్పుడు ఇది limiting అయితే ఇది excess అయినట్టే కదా. Yeah, just put it. So calculate with respect to limiting reagent. See, for every 4 moles how much we required? 2. Then for every 2 how much it should be? 1. So out of these 2 moles 1 mole is reacted, 1 mole excess. Done? Yeah. Then next, for every 4 moles how much you are getting this? Then for every 2 it should be 2. అంటే what is your theoretical yield? అంటే ఈ ఈక్వేషన్ ప్రకారం చూసుకుంటే మనకి ఎంత రావాలి? 2 రావాలి. సో ది థియరిటికల్ yield is 2, but experimentally what they are saying, how much amount of C is formed? So that is experimental yield. Experimental yield is 1 mole. So now they are asking you to find theoretical yield. Theoretical yield is 2. Experimental yield they only give it. Next they are asking what is a percentage yield. So percentage yield is nothing but see, any reaction if you do, first మనం ఏం చేస్తాం, థియరిటికల్గా పేపర్లో క్యాలిక్యులేట్ చేస్తాం కదా. సో వాట్ ఎవర్ వీఆర్ డూయింగ్ థియరిటికల్లీ, దట్ ఈస్ కాల్డ్ థియరిటికల్ yield. సో యాజ్ పర్ అవర్ థియరిటికల్ క్యాలిక్యులేషన్స్ హౌ మచ్ అమౌంట్ ఆఫ్ ప్రోడక్ట్ షుడ్ బి ఫార్మ్? 2. బట్ రియాలిటీలో ఎంత వచ్చిందంట? ఇన్ రియాలిటీ ఎక్స్పెరిమెంట్ ఇఫ్ దే డూ, హౌ మచ్ ప్రోడక్ట్ దే గాట్? 1. సో ద రేషియో ఆఫ్ దీస్ 2 ఈస్ కాల్డ్ percentage yield. So percentage yield is nothing but experimental yield by theoretical yield into 100. See, చెప్పండి, ఎక్స్పెరిమెంటల్ yield ఎక్కువ ఉంటుంది, థియరిటికల్ yield ఎక్కువ ఉంటుంది ఎప్పుడైనా? థియరిటికల్ yield will be more. So in our real life also it same scenario. మనం ఏదైనా పని చేద్దాం అనుకుంటాం, మనం అనుకున్న దానికంటే చాలాసార్లు తక్కువనే చేస్తాం. వాట్ ఎవర్ వి అజ్యూమ్ we will do less than that or equal to that. We won't cross anyways right now. So if it is equal, we can say it is 100%, but most of the cases less. So in reality it will be always less when we assume, like when we dream something, this will be the scenario. Okay, generally I am saying. Okay, yeah, so tell me, so how can you write experimental yield is how much? 1. Theoretical is how much? 2 into 100. So 50. So what is the formula to calculate percentage yield? Experimental yield by theoretical yield into 100. Okay, done with this? Yes, you can write. So whenever you are seeing something like this about product, it means it is a theory, it is a experimental yield value. Have you tried any questions from modules? చేసారా మేమన్నా? తీసుకోలేదు వచ్చి modules. Okay, next. So one more thing, there is something called percentage composition. and also empirical formula we'll be discussing. See, percentage composition is of two types. One is by mass percentage, by mole. So we'll understand this by taking a simple example of methane. Okay, so in methane, if I ask for mass percentage, so just see what is the total mass of methane. Carbon 12 plus 4 hydrogens, so total mass is 16. Total mass is 16. Now if I ask by mass, percentage by mass, so let us say carbon percentage by mass if I want to do. So what I should do? Mass of carbon by total mass into 100. అదే మాస్ పర్సెంటేజ్ ఆఫ్ హైడ్రోజన్ అడిగితే ఏం చెప్పాలి చెప్పండి? మాస్ ఆఫ్ హైడ్రోజన్ బై టోటల్ మాస్ ఇంటూ 100. అంటే ఇక్కడ ఏం రావాలి? వాట్ ఈస్ ద మాస్? ఐ షుడ్ రైట్ హియర్ weight of carbon. Okay, let's write one formula, then weight of that carbon or whatever the thing they are asking by total weight into 100. Yes, do it. How much? Total weight, I mean weight of carbon is 12 by total weight 60 into 100. So this will be 3 4s 25 75%. So similarly if I ask for hydrogen, weight of hydrogen, that is 4 by 16 into 100. So this is 4 times, this is 25%. ఇది అర్థమైందా? Okay, so we will do one more example question after this. Yeah, just look at this mole percentage. If I say 1 mole methane, ఏమంటున్నా 1 mole methane, in 1 mole methane how many moles of carbons you are seeing? 1 mole of methane లో ఎన్ని కార్బన్స్ కనిపిస్తున్నాయి? 1 mole carbon. And how many moles of hydrogens we have? 4 moles of hydrogens we have. So this is mass percentage, this is mole percentage. Now check percentage of carbon by mole. See, if the question does not include by mass, by mole, you consider it as by mass. If question particularly says about mole percentage, you do like this. Percentage of carbon by mole is equals to, అప్పుడు ఏం చేయాలి న్యూమరేటర్లో? మోల్స్ ఆఫ్ కార్బన్ బై టోటల్ మోల్స్ ఇంటూ టోటల్ మోల్స్ ఎన్నమ్మా? 1 plus 4, that is 5 moles. So in the denominator it should be 5. Here 1 into 100. So ఇక్కడ ఎంత వచ్చింది? 20%. Okay, next percentage of hydrogen by mole. What? 4 by 5 into 100. So it will be 2080. See, there is complete difference in the answers by mass, by weight, by mole. See, by mass, if I say carbon weight is almost 75, but here it is just 20. So you should be careful what type of question they are making. Okay, write this. Once try this question. Percentage of nitrogen in urea. What is the formula of urea first? NH2 CO NH2. So you can remember the structure itself like this. Yeah, do this. Percentage of nitrogen in urea. So tell me, what is its mass? 60. So 2 nitrogens, 28, like 14 for each. How many nitrogens? 2. Each one is 14. How many hydrogens? 4. Each one is 1 plus 1 carbon, 12 plus 1 oxygen, 16. So it is 28 plus 4 plus 12. So it will be total 60. Okay? Yeah. So now what I am asking? Percentage of nitrogen. So what I should take? Weight of nitrogen by total weight into 100. So it is 28 by 60 into 100. So it will be how much? 6 4s are 24. Okay, 24 means remaining 4. 6 are 36, like 4 into 40 means 36. Okay, around it will be 46.6%. Okay, yeah. So percentage composition also clear. Okay. Next topic is about empirical formula and molecular formula. What makes the difference between empirical and molecular formula? See, you know the formula of glucose, like C6H12O6. So now take, this is a molecular formula. Molecular formula of glucose, right? Now just try to take a one possible number so that it becomes a simple whole number ratio. Chudandi, I can remove here 6 తీయండి ఒకసారి C1 H2 O1. So what I have taken here outside 6. So ఒకసారి whatever the formula you got here, what is that? CH2O. So this is the simplest representation of this chemical formula kada. So you can call this kind of simplest representation as empirical formula for this molecular formula. So what is the empirical formula of glucose? CH2O. Once read the statement. An empirical formula represents simplest whole number ratio of various atoms present in a compound. See, we have various atoms in the compound. What is the simplest whole number ratio we got? That is empirical formula. Okay, and the molecular formula shows exact number of different types of atoms. How many carbons are there here? 6. Exact number is there, na? So that is molecular formula. We got this too. Now if I say this is empirical formula, what makes the relation between them? So all the time molecular formula will be equals to empirical formula into some number like this, right now? So that number I am taking it as n. So what is this n? N can be something like 1, 2, 3, 4, so on. Okay, right. So tell me, what is the empirical formula for acetic acid? This is a molecular formula I am saying. What is the empirical formula for acetic acid? Huh? How many carbons? 2. Hydrogens? 4. Oxygens? 2. Yes. Take simplest ratio. CH2O. This is the empirical formula. What is the N value we got here? 2. Okay. So benzene formula is C6H6 ma. Then what is its empirical formula? CH. N value is 6. Done. Okay. So one more thing here you need to know is, okay, so the basic relation what we got? Molecular formula is equals to empirical formula into N. So if I want N, I can say it as molecular formula by empirical formula also. Even if I have molecular weights and empirical formula weight, then also I can get the N value. Okay, see, molecular formula weight will be equals to empirical formula weight into N. Can I do like this? Molecular formula weight equals to empirical formula weight into N. So both can be used. Okay, we will do 1-2 questions on this. You just write this. రాయండి, ఇది రాసిన తర్వాత ఒక 2 క్వశ్చన్స్ చేద్దాం. So just take the ratios mass of that element to the total weight. If they are satisfying this rule, that is your answer. Done? Okay, let me try two options, you can try later. So just check this. Percentage of carbon if I want, how many carbons are there? 6 into 12 I can write in the numerator. In the denominator 6 into 12, that is 72 plus 6 hydrogens. So total 78. So here it should be 78. So it is something like 72 by 78, right? So just see that values, they are very close now. Very close means it is around 9 times. Like see, into 100 now. Into 100 means, see ma, this is 78. Which table will get the 70 to hundreds? So around more than 90% we can expect. But they are asking carbon weight should be 80. So no need of calculation. Okay, next go through this option. So percentage of carbon means 2 carbons, 24, 24 plus 6, 30 into 100. Yes, this is 0. So this is 8 times. So exactly 80 we got here. So this should be your answer. Okay, if you want you can cross check for BC. Okay, yeah. Clear now? So this is like option verification only. Okay, so now just quickly tell me what are the things we discussed from last few classes of mole concept. What we discussed, the complete story of mole concept, like conversion of given weight into number of moles to Avogadro's number, and also to the volume. Okay, just give me that final relation that I mentioned in the previous classes. Number of moles can be interlinked with the given weight. How it can be? If weight is given, we can convert into number of moles by just dividing it with molar mass. We will get this. If I give number of moles, I will get weight when I multiply with molar mass. This is fine. Next, if number of moles is given, asking how many particles or how many entities. Number of entities, yeah. What I should do? Number of moles into Avogadro number. If I give number of entities only, particles only, how you will get number of moles? Divide it with Avogadro number. Next. And if they are asking about any electrons, any particular atoms, you should multiply that with atomicity also, depending on question. Next. Number of moles to the volume at STP, volume of gas at NTP condition, if I say. Yeah, what should be the thing? Number of moles into 22.4 liters. Why only 22.4? Because 1 mole occupies 22.4 liters. N moles occupies N into 22.4. Ade ikkada nundi akkadikante volume is given, divide that with 22.4 liters. Okay, that's it. Okay, fine. Next. We did some questions also on this. The next we studied about stoichiometry calculations and all. Now we will be discussing about concentration terms. Concentration terms means see, in chemistry we'll discuss the solutions as more concentrated, less concentrated, something like this kind of terms we'll use. Like an acid is highly concentrated, we say. So what do we mean by concentrated, diluted, all these terms? So it means, consider I have a beaker of water. To this I am adding salt or sugar. Okay, so now the amount of the substance you are adding, like for example you are adding sugar to this. Okay, so quantity of this sugar added to water is expressed in terms of concentration terms. So the amount of this sugar added into water can be expressed in terms of concentration terms. So now we have different concentration terms like weight by weight percentage, weight by volume percentage, molarity, normality, all these are there. Okay, so we'll discuss one by one. First of all, how to define a solution. ఫస్ట్ ఇందులో ఏముందమ్మా, మనకి ఓన్లీ వాటర్ ఉంది, దానికి ఏం యాడ్ చేసాం? సో ఓన్లీ వాటర్ ఉన్నప్పుడు దాన్ని సొల్యూషన్ అనొద్దు, యూ షుడ్ కాల్ ఇట్ యాజ్ ది సాల్వెంట్. వాట్ యూ షుడ్ కాల్? సాల్వెంట్. అండ్ ఐఎమ్ యాడింగ్ షుగర్ నా, సో దిస్ షుడ్ బి కాల్డ్ యాజ్ సొల్యూట్. Solute added to solvent, that results to form a solution. Again, solution comes from where and where? One is solute, the other one is solvent. Okay, sir, how you are saying water as a solvent here? Why don't you say this as a solvent? Generally this confusion will be there. So identify, after adding sugar, what is the physical state of solution? See, sugar I am writing, water I am writing, and sugar solution I am writing. What is the physical state of water? Liquid. And physical state of sugar? Solid. What about the physical state of this sugar solution? This is also like liquid state only. Aqueous medium means what is that? Liquid only, no? Okay. So you can identify the solute and solvent from the given composition looking at the physical states. What is the physical state of solution? Liquid. That should having same physical state like our solvent. So solvent and solution have same physical states. Once again, solvent, solution has same physical state. So ఇందులో ఏది సాల్వెంట్ ఏది సొల్యూషన్ అంటే ఎలా చెప్పాలి మనం? సొల్యూషన్ అండ్ సాల్వెంట్ షుడ్ హ్యావ్ సేమ్ ఫిజికల్ స్టేట్. డోంట్ సే విత్ రెస్పెక్ట్ టు క్వాంటిటీస్, సే విత్ రెస్పెక్ట్ టు ఫిజికల్ స్టేట్. ఏంటి ఫిజికల్ స్టేట్స్ ఎలా చెప్పాలి చెప్పండి? సొల్యూషన్కి సాల్వెంట్కి సేమ్ ఫిజికల్ స్టేట్ ఉంటుంది. Okay, so example here I am writing, copper sulfate is a solid substance. To this I am adding quantified amount of water in order to make copper sulfate dot 5H2O. So this is also solid now. Now identify solute, solvent and solution in this. Liquid, this one. Yeah, tell me. Identify solute and solvent. Yeah, so what I told, just look at the physical states. Physical states are same, that is considered as solvent. Physical state of solvent is same as the solution. This is the main important point. Okay, మరి కొన్ని కేసెస్లో we will be having solution, solute, solvent, all of them have same physical state. Best example ఏంటి? We use, we'll take alcohol plus water gives alcoholic solution, whatever it may be. So it will be liquid, this is also liquid, this is also liquid. So how to identify in this case? So here, if physical states all of them are same, use quantity method. Major quantity solvent, minor solute. So generally major quantity means water, so it can be considered as solvent, the remaining thing is solute. అర్థమైంది కదా? ఓకే, ఫస్ట్ ఏంటమ్మా? ఫిజికల్ స్టేట్. ఫిజికల్ స్టేట్స్ అంతా సేమే ఉంటే క్వాంటిటీ చూసుకోవాలి, ఇవి రెండే. ఓకే, యా. సో లెట్స్ ఎంటర్ ఇన్ టు దిస్. ఓకే, ఒకసారి రాయండి. సొల్యూషన్ మీన్స్, వాట్ ఇస్ ద డెఫినేషన్ ఆఫ్ సొల్యూషన్? సొల్యూషన్ మీన్స్ సొల్యూట్ ప్లస్ సాల్వెంట్ అనేది ఒక స్ట్రక్చర్, సొల్యూషన్ యొక్క స్ట్రక్చర్. సో డెఫినేషన్ మీన్స్ యూ షుడ్ సే ఏ హోమోజీనస్ మిక్చర్ ఆఫ్ 2 or more components. Once again, it should be a homogeneous. Heterogeneous unte dani solution anoddu. So it is a solution is a homogeneous mixture of 2 or more components. Okay, write that. Solution ante definition rashesi solution is a mixture of two or more homogeneous mixture of two or more components. Done. Then next basic structure and solute plus solvent gives solution. Then next identification methods. Emuna identification methods. Solute and solvent must have same physical state. Solvent and solution must have same physical state. Second method enti, if all physical states are same, then wait, then more quantity is considered as solvent, less quantity as solute. Done. Okay, next sugar syrup తెలుసు కదా, sugar syrup అంటే everyone knows. Yes, so sugar syrup generally contains sugar plus water, but sugar quantity is almost 60%, water quantity let us say only 40% maybe. Okay, and it is syrup means syrup will be in the liquid state only na. Yeah, sugar solid, this is liquid. So which is solute, solvent, tell me? So here no matter how much quantity it is, look only at physical state. So this is our solvent, this is solute. Write this example also. Okay. Okay, next thing is, see if you observe any sanitizer bottles, so they will be giving you something like this as 75% on it. Okay, or you can observe any alcoholic bottles also, so it will be mentioned with 35% or 40%. You can observe whiskey bottles, anything, it will be mentioned like this, just for observation only na. Yeah, so it will be mentioned as 35%, 40%, 50%, sanitizer bottle as 75%. So what does it indicates? It indicates percentage na. So if it is 75% means 75 by 100. Okay, so for every 100 ml of this solution, 75 ml of that solute is present. Okay, generally alcoholic solution means what? 75 ml of alcohol present in this 100 ml of solution. Solution is generally made up of water plus this alcohol, I mean in this case. Okay, so 75 ml ఏమున్నట్టు sanitizer bottle లో 75 ml of alcohol and remaining 25 ml of water. So together it is acting as a sanitizer. But in alcoholic bottle, I mean normally whiskey bottle or anything, if you consider, it is only 35. So 35% means what? 35 ml of alcohol for every 100 ml of this solution, whatever the bottle you can say. Okay, is this clear or not? Ardhamainda meeku? Okay, so why I am saying this particular example only means, depending upon the strength, and strength means what? Depending upon the quantity of solute, quantity of alcohol, we are using in different ways. This will be consumed by many people, like some people, but this cannot be consumed. Okay, even there are many deaths reported in case of COVID time. You have seen it as due to unavailability of alcohol, they were taken these sanitizers and yeah, they got dead also. Okay, so we have many cases like that right now. So because it is highly concentrated, right? So now what I am using the word concentrated. This is defined by what? Quantity of the solute present in the solution. Solute present in the solution. Okay, yeah. So I can say this as a concentration term example. So how I am defining 25 ml, 75 ml, 30 ml like that in 100 ml. Na? So there are two things. One is weight by volume percentage. Other one is weight by weight percentage. So what does it mean? Volume by volume means volume of solute in 100 ml of solution. Entama definition? Volume by volume percentage means what? Volume of solute present in 100 ml of solution. So formula ela radham mari? Volume by volume percentage is equals to volume of solute by total volume of solution into 100. What is the volume by volume percentage? Volume of solute by total volume of solution into 100. Okay. Next, weight by weight percentage means, then you can define it. Weight of solute by total weight of solution into 100. Yeah. So you can write weight of solute by total weight of solution into 100. For example, there is something like this. 30% or 30% weight by weight percentage of NaOH solution. Something like this, we have a line. So what does it mean? Tell me. 30%, which percentage it is? Weight by weight of NaOH. And ardham enti? That is 30 grams of NaOH present in 100 grams of solution. Once again, 30 grams of NaOH present in 100 grams of solution. Ade ikkada weight by weight gaakunda volume by volume is the that 30 ml of that component present in 100 ml of the solution. అర్థమైంది కదా డెఫినేషన్ లైన్స్. యా. నెక్స్ట్ వెయిట్ బై వెయిట్ అయిపోయింది, వాల్యూమ్ బై వాల్యూమ్ అయిపోయింది. నెక్స్ట్ ఏంటి? వెయిట్ బై వాల్యూమ్ పర్సంటేజ్. ఇది కూడా మీరు డిఫైన్ చేయొచ్చమ్మా, చెప్పండి హౌ టు డిఫైన్. ఎస్, వెయిట్ ఆఫ్ సొల్యూట్ బై టోటల్ వాల్యూమ్ ఆఫ్ సొల్యూషన్ ఇంటూ 100. ఓకే, మరి న్యూమరేటర్ వాల్యూమ్, డినామినేటర్ వాల్యూమ్. సో వాల్యూమ్ యూనిట్స్ ఆర్ లీటర్, ml, get cancelled. So volume by volume percentage, no units. We don't have any units. Weight by weight percentage, no units. Weight by volume percentage, yes, we have units. So it can be like gram per ml. Gram per ml. Okay, units. Units also important, ma. Okay, done up to here. Yes, next. వీలైతే రాయండి ఫస్ట్గా. నెక్స్ట్ ఇంకొక టర్మ్ ఒకటి ఉంటుంది చూడండి, ఎఫెక్ట్ ఆఫ్ టెంపరేచర్, టెంపరేచర్ ఎఫెక్ట్. సో వీ నో ఇఫ్ వీ ఇంక్రీజ్ ద టెంపరేచర్ వాట్ హ్యాపెన్స్ టు వాల్యూమ్. టెంపరేచర్ ఇంక్రీజ్ చేస్తే వాల్యూమ్ ఏమవుతుంది అని అడుగుతున్నా. See, for example, there is a container. Now what happens if there is any gas molecules, for understanding purpose I am taking. If you heat this, their kinetic energy increases, their gases will expand upon heating, we will study now. So when you increase the temperature, what happens to volume? Volume increases. Volume also increases. If volume increases, look at the terms here. weight by volume I have written. I have measured this at 25 degrees Celsius ma. Now second measurement I am doing at some 90 degrees Celsius. Will the value remain same or changes? Changes. Why changes? Because this volume term is changing when I change the temperature. Initially it will be less. When I increase the temperature, volume value also increases. So total value becomes something different. So this is called effect of temperature. So in which case you are going to see the effect of temperature? Yeah. In all the concentration terms, wherever we see volume. Once again, effect of temperature ekkada kanipistundanta? All concentration terms, wherever we see volume. Indulo volume term undiga. So this is a temperature dependent. What about this one? No. This one? Yes. So you can write beside this temperature dependent if you want. Dependent. లేకపోతే ఒక సింగిల్ లైన్ రాయొచ్చు. Wherever volume term is involved, all those are depends on temperature, are affected by temperature. Okay. Done up to here? Next one. Chudandi. This is important. Again I am taking a beaker containing 1 liter of water. What I am taking? Beaker containing 1 liter of water. So to this I am adding any solute. You want, you can add sugar only. Okay. So generally we will add in terms of grams now. Okay. So now what you did? Added solute. Weight of solute added for 1 liter of solution. What you did? Weight of solute added for 1 liter of solution. So this is called strength of solution. Emanaldani? Strength of solution. So what is the definition of strength of solution once? The amount of, cheppandi, the amount of solute added in 1 liter of solution, or amount of solute present in 1 liter of solution. Is this clear? So what you can write it as? Strength of solution. So strength of solution ante entamma? Amount of solute present in 1 liter of solution. Amount of solute here you should say in terms of grams. In terms of what? Grams. Volume is how much I take it? 1 liter. So simply what is the units of strength of solution? Gram per liter. These units are important first of all. So gram per liter, no? Yeah. What is the formula you should make? Strength of solution means, should write weight of solute in what? Grams by volume of solution in liters. That's it. This is the formula. Okay. Tell me, it is temperature dependent or independent? Dependent, because volume term is involved. Write this. Done? Yeah. Next. One more term is called molarity. What is it? How to define molarity? ikkada emannama? Grams of solute added into the water. Ippudu emantunna? Instead of saying in terms of grams, I am saying in terms of moles. Number of moles of solute present in 1 liter of solution. So what is the definition? Amount of or number of moles of solute in 1 liter of solution. In 1 liter of solution. Same to the strength of solution. There we see in grams. Here we are seeing moles. Only small difference. So what will be the units then? Mole per liter. So now tell me the formula. Molarity capital M equals to number of moles of solute. I am indicating with NB. Means what? Number of moles of solute by volume of solution, that should be in liters. Okay? Yeah. So now once again write this. Molarity equals to NB by V of solution in liters. Okay. So NB ante enti? Moles of solute. So number of moles I can write as weight of solute by molar mass of solute. రాయొచ్చు కదా ఇది ఇంటూ లీటర్స్లో రాసానమ్మా. ఇఫ్ ఐ వాంట్ టు రైట్ ఇన్ ఎంఎల్, you multiply this with 1000 by volume, you can express in ml also. This formula also known. Now you just see what I am doing. Weight of solute as it is by V means what ma? Volume of solution. Volume of solution into 1000 is there now, I am writing 100 into 10 by molar mass of solute. So just see this one, weight by volume into 100. What I can say this one? Which percentage? Weight by volume percentage, mass by volume percentage అని రాయొచ్చుగా. సో నెక్స్ట్ ఏమని రాస్తున్నా? మొలారిటీ ఈక్వల్స్ టు weight by volume percentage into 10 by molar mass of solute. Okay? అంటే we discussed about molarity and relation of molarity with some other concentration term. అంటే some other అంటే ఏంటి ఇక్కడ? Weight by volume percentage. ఓకే, సరే కొన్ని క్వశ్చన్స్ చేద్దాం సో దట్ యూ వోంట్ ఫీల్ బోర్డ్. ఫస్ట్ ఇవి రాయండి. రాసారు ఇవి? స్ట్రెంత్ ఆఫ్ సొల్యూషన్ రాసారమ్మా? రాయండి. Okay. Next, can you try to link between, relate with molarity and strength of solution? Relate strength of solution with molarity. Compare them, you will get a relation. ఏమంటున్నా? Molarity and strength of solution. రెండు ఫార్ములాస్ పక్క పక్కన రాయండి, మీకు ఒకటి క్లారిటీ వస్తుంది. రావట్లే? ఫస్ట్ చెప్పండి అమ్మ. మొలారిటీ ఫార్ములా నెంబర్ ఆఫ్ మోల్స్ బై వాల్యూమ్. నెంబర్ ఆఫ్ మోల్స్ ఆఫ్ సొల్యూట్ బై వాల్యూమ్. నెక్స్ట్ స్ట్రెంత్ ఆఫ్ సొల్యూషన్ ఆల్సో weight of solute by volume. So denominators are same, small difference in numerator only. What is the difference? So how can I write number of moles as weight in terms of weight? మనకి అది ఉంది కదా, గివెన్ వెయిట్ ఆఫ్ సొల్యూట్ బై మోలార్ మాస్ ఆఫ్ సొల్యూట్. దిస్ ఇస్ బేసిక్ రిలేషన్ ఫ్రమ్ మోల్ కాన్సెప్ట్. ఓకే, యా. సో ఈ ప్లేస్లో నేను ఇది రాయొచ్చా? అప్పుడు చూడండి, మొలారిటీ ఈక్వల్స్ టు గివెన్ వెయిట్ ఆఫ్ సొల్యూట్ బై మోలార్ మాస్ ఆఫ్ సొల్యూట్ ఇంటూ 1 by V, volume. So can I write volume that side, this one this side? Yeah. So now tell me. Volume here, molar mass this side. So look, weight by volume, strength of solution. So molarity is nothing but strength of solution divided by molar mass of solute. That's it. So sometimes they will give you strength of solution, ask for molarity. So what is the relation you can use? Molarity equals to strength of solution by molar mass of solute. Done? Too much? Okay, do one question on molarity. Simple question. 90 grams of glucose, right? 90 grams of glucose added to water to make 250 ml of solution. 250 ml of solution. Calculate molarity and also strength of solution. Calculate molarity and also strength of solution. Yes, do these two questions, very easy. Once again I am repeating, 90 grams of glucose is added to water to make 250 ml of solution. Calculate molarity and strength of solution. Yes, any answers?
Molarity
2, everyone? So molarity adugutunnam kada. So what to do? Given substance is glucose solute, that is 90 grams. What is the molar mass of glucose? 180. We know this. Next, volume of solution, how much I told you? 250 ml. Yeah. So now what is the relation between molarity and solute weight? Weight of solute by molar mass of solute into 1000 by volume of solution in ml. Okay, so it is 90 given weight, molar mass is 180 into 1000 by 250. So this will be 4 times, this will be 2 times 2. So 2 molar solution we can say. Now I am asking about, do that and tell me. Strength. Done? What is the relation? Molarity into molar mass of solute gives you strength of solution. Yeah. So here it is 2 into 180. So it means 360. Means what does it mean by this 360? 360 grams of glucose is present in 1 liter of solution. Okay. సింపుల్ రా 250 ml ఎంత ప్రజెంట్ ఉంది దీన్ని 1 లీటర్ చేయండి అంటే ఇంటూ ఎంత చేయాలి అప్పుడు దీన్ని కూడా ఇంటూ 4 చేయండి అదే ఆన్సర్ వస్తుంది ఓకే అట్లా కూడా అర్థం చేసుకోవచ్చు ఓకే యా సో స్ట్రెంత్ ఆఫ్ సొల్యూషన్ బేసిక్ డెఫినేషన్ అర్థమైందా హౌ మెనీ గ్రామ్స్ ఆఫ్ సొల్యూట్ ఇన్ 1 లీటర్ ఆఫ్ సొల్యూషన్ ఓకే నెక్స్ట్ Okay, write a question. Zero 0.4 percentage of 0.4 percentage. Which percentage? Weight by volume percentage. 0.4 weight by volume percentage of NaOH is given. Calculate its molarity. Calculate its molarity and strength. Calculate its molarity and strength. Calculate its molarity and strength. Yeah. Molarity is 0.1 and strength. So question is 0.4 percentage NaOH is given. Calculate molarity. So 0.4 weight by volume percentage is mentioned. So now what I can take? Molarity equals to, what is the relation we got between molarity and weight by volume percentage? Molarity equals to weight by volume percentage into 10 by molar mass of solute. So this is 0.4 into 10. Molar mass of NaOH is also 40. So it is 1 molar. What is that? It is a 1 molar solution. So the next, strength of solution, how to find? Strength of solution equals to molarity into molar mass of solute. So molarity is 1, molar mass becomes NaOH is 40. So strength of solution is 40. Ante strength of solution 40 ante ardham enti? What does it mean? 40 grams in 1000 ml of or 1 liter of solution. So strength means always take for 1 liter. Yeah, any doubt? Yes. So just take any PYQ book or our modules or anything, solve questions from first chapter, Mole Concept, up to concentration terms. Okay? 40 by 0.4 into 10, 40. Oh, sorry. Okay. Sorry. 4. Okay, 4 by 40. So this is 0.1. Sorry. So the next, molarity is how much? 0.1. Molar mass is 40. Yeah, then this is 4. Yeah. Done? So we will continue the same discussion tomorrow, concentration terms, but by the time you practice some questions.